Hello, welcome back to Geotech Solutions, whereby today we will be looking at watershed delineation in QGIS using the glass tool. First, let's start by saving our layer. We'll save our layer as watershed delineation. Yeah, we save our layer here as watershed shed, watershed delineation. We'll save it. Then let's load our layers. So we'll load our last layers. That is the SLTM digital elevation models. So I'm going to my local disk. Okay, and I just will select all and open, and I will add all my layers. Okay, that's about it now. You can see I have my layers. And the next thing I will do is I will merge all my layers so that I can delineate an area of study. So I'm going to get your processing tools. No. Last time is linears and merge. Okay, I'll merge all my layers and select all. And okay, then I'll save my layer to file as merged. Okay, I have to navigate to my folder, merged that way, and I will save. Okay, then I will run my algorithm. Okay, I'll close now after I've merged. Do not have this, so I'll just remove the rest. I don't require this, so I'll remove layers. Okay, yes. Okay, now the next thing is I'll load my layer. I'll load my vector layer, that is the Kenya county for counties in Kenya. Or since I have my layer, or if you don't, you just create a polygon for your area of interest. Now my area of interest, I will be using a county by the name Embu. I will use this county, Embu County. I'll delineate watershed using Embu County. Okay. Now let's click Embu County. Zoom to layers. I'll open attribute table for Embu County. Then I'll search Embu County. Okay, I've seen it. I'll select it and I'll just close the layer. Now my Embu is selected. Go to vector, do processing tools and clip. Okay, I'll clip Embu County. Save the file. Embu clip. Okay, that way. I'll save and I'll run. Now I have my Embu clip. Okay, I don't want this one, so I remove the layer. So I have my Embu, so I'll just remove the background color. Okay, apply. You notice I'm doing it a little bit fast because all these have been explained in my previous video. So I'll clip Embu County. So I'll go to raster extraction, clip by mask layer. So my input will be merged. Mask layer will be Embu County. Then I'll come here and save it as I'll save it as my study area. I'll save it as my study area and I will run. So I have my study area. Now I don't remove layer. No. I won't remove a book clip. I just want to remove the merged one. Okay, that way. Now I want to bring this on top there. So I'll just remove this background, this the black color. So I'll go to properties and I'll come to symbology and I'll just transparency. I'll just input the additional node data value 0. So I'll apply and okay. Now I have my clip. Now the next thing we are going to do is we are going to go to our raster or our processing toolbar. You can visualize it here in the processing menu. So I'll search r.fill, search r.fill. Okay, this one. Now the main purpose of this tool is to fill the sinks. Okay, the sinks or the depletions in our data. Okay, I think I had explained it very well in the I was using the Saga tool. Kindly, I will paste the link in the description so that you can go and see how the sinks are filled. Okay. Now let's save it. This is our save to file is our filled dem. Filled dem. Okay. Save. Then I run. Okay, after it has completed run now. Okay, okay, now it's okay. Although I forgot something, but it's okay. Now I have my filled dem, right, and my emb clip. Now let's learn something else called r. Now the next step we are going to search r.watershed, r.watershed that way. So our first step is always to fill the depletions in our data. Now the next step is the r.watershed. So our input will be our filled dem, then maximum minimum size of exterior watershed basin will set it as I'll set it as 2000. Okay, now minimum size of exterior watershed basin simply means like the pixels which will be used or included in delineating our watershed basin. If you go for a larger area, for example, if I go for an area, let's say of 10,000, uh, that means that our watershed basin will generated from more pixels. That meaning it won't be that very accurate. But if I go for a smaller area, for example, an area of 1,000 meters, so it means that our watershed will be delineated, or the basin will be delineated from more pixels, meaning it will be more detailed. So if you want a watershed for a larger area, just go for a larger value. But if you want for a watershed for a smaller area which is more detailed, go with a smaller value. Okay, then I'll enable single flow direction D8. Then here I'll save this as flow accumulation. Here I'll save this as flow accumulation. Okay, that way save. Then this one I'll save it as flow direction. Flow direction. Save. Okay. Now then I'll just come here and untick the rest. Okay, then I will run. just completed running. Now you can see I have my flow direction and my flow accumulation. So let's zoom to layers. This is my flow accumulation. Now these are the black. You see, now I have my some blue colors here and some colors here, but these are the black. This is originally the black part which we assign the data value of 0. Okay, you see, to get rid of it, you just clip or you just clip this area, but we are just going to work with it since our study area is embu and we'll clip it afterwards. Okay, now let's continue the book clip. Now let's first of all focus on the flow flow direction. Okay, then I'll untick the study area. Okay, for first of all, direction. Okay, flow direction simply means the direction of flow of the rivers. Okay, the direction of flow of the rivers is basically from northeast, east, southeast, south, southwest, west, and northeast, northwest. Sorry. So now we want to assign the direction to our flow direction layer. So I'll go to properties and I'll go to symbology. Okay, here we are going to use the pattern unique values. Okay, then we will classify. After we classify, you will realize that we have -8, 8. Okay, but we want only to have from +1 to +8. I'll apply. Okay. Okay, after I have applied, you will notice now my area has changed. Like, okay, sorry for that. Okay, notice my area has changed. Now let me show you how you get rid of the negatives. You see, let me show you how you get rid of the negatives for the flow direction. Okay, let me show you how you get rid of the negatives for the flow direction. So we will do raster calculator. Okay, and we'll start by opening the bracket and then say if flow direction is less than 0, if flow direction is less than 0, then multiplied by -1 multiplied by flow direction, that is the negative equation, our negative equation, add it to flow direction greater than or equal to 0, close the bracket, multiplied by, instead of just simply multiplying it by 1, and since 1 times flow direction adds up to flow direction, so we just input our flow direction, and here we will save this as river local disk. See, okay, you have to save it into your folder. I'll save this as flow. I'll save this as flow direction 1, that way, and I will save and I'll say okay. Now you will notice I have, now I don't require this one. I'll remove the layer. Okay, now you notice I have my values now have changed to 1 to 8. Now let's style it a little bit. I'll go raster, okay, to symbology, sorry, single bad pattern unique values, that way, classify, apply, and okay, now you can see now our flow direction has some positive colors. Now let's head back to properties and I'll show you why. No, you see, now simply these values move in a clockwise direction, a clockwise manner, starting from north. So we'll just rename them. This will just name this as north, northeast, east, southeast, south, southwest, west, and northwest, and apply, and okay. Now we have a flow direction. Zoom to layers. We have our flow direction now. We have our flow direction layer. Now we can keep the extra part. So I'll just activate my boundary and bring it on top there. So let us try and see if the transparency will remove the path 0. Apply, and okay, the transparency has done. And so we just go to raster extraction, clip by mask layer. Okay, flow direction mask layer will be book clip. Then we'll save, we just save this as, okay, save it as flow direction 1. Yeah, just okay, flow direction 1. Then we'll run. Okay, now flow direction has been clipped. Yeah, now flow direction has been clipped. Okay, think we I think we were to clip before we classified, but after all it's just the same. We have our flow direction now this way, but no problem. We just do the classification again. So single bird at unique value, classify. This should be northeast, east, southeast, south, southwest, west, and finally we have one northwest. Okay, apply, and okay. Okay, basically you should clip before you classify. Okay, now we are done with that part. Now we want the flow accumulation. So the flow accumulation, we just clip it just to get rid of the colors, but you can choose to work with the colors and clip your study area afterwards, the watershed delineation or the catchment area afterward, but the you might be forced to redo the holding. But let's just first of all clip it and classify it, because this okay. No, the reason for this is that these pixels have no data. That's why they appear here. Okay, now we'll go to last extraction by mask layer, book clip flow. It will be flow accumulation. Okay, since we want to clip flow accumulation, we'll flow accumulation that way. You just save this as save it as flow. Okay, disk C. We'll save this as flow accumulation that way, and we'll save. Yes, run. Okay, it has brought us some error. Close. I think I had some error. So we want to clip the flow accumulation. So we go to extraction, clip by mask layer, book clip. Yes, flow accumulation. Yes, that one. Then we will run without saving. Okay. Okay. Think you can see now. am I going? Okay, I think that one won't work. Okay, let me remove the layer and let's try clipping again. If it doesn't, if it won't work well, just continue. Okay, accumulation. Then I will save the file as disk C. I save it as accumulation. Accumulation that way. Save and run. Now you see now our accumulation. They can't clip our accumulation. It brings such adding, but we'll just work with it the way it is. Okay, remove layer. Let's work with it just this way, but you will just assume that this part is not part of our data. We just want to delineate a catchment area for one particular river in Embu County. So the next thing is we head back to raster calculator. Now we want to give the flow accumulation, and we want to the raster calculator for flow accumulation is that we want to delineate, or we want to give a specific threshold which makes a stream. Okay, for example, if a threshold of 500 pixels will make a stream. Okay, now let me show you. Then we'll say flow accumulation should be greater than 2000. Let me put 2000, and I'll see if flow accumulation is greater than 2000, then call it a river. Okay, then call it a river that way and save. Then okay. Now you'll notice now that the let me edit this layer properties. Okay, before we head to properties, now these are the main rivers which the flow accumulation is greater than 2000, meaning the pixels which has been used are more than 2000 to make a river. Okay, now if you want a more defined one, you go for smaller area. Remember what I told you. If you go for 1000, you will have fewer rivers but more accurate. If you go for 10,000, you have more rivers, less accurate. Okay, but let's use the 2000. You note we have used the 2000. We will the 2000 which we have used, we will use it later. Now let's go to properties. Okay, properties, and then you come to add unique values and classify. Now we classify, we don't want zero values, so we'll just minus it and we'll make this one blue. Okay, we'll make it blue. Yeah, this is the blue, and then okay, and apply, and okay. Now if I untick this, you can see now I have my rivers. Now you can see my rivers are well defined. Okay, now these are the main rivers. Okay, now these are the main rivers. I want to give them we can generate the streams for the main rivers. Okay, yeah. Then after that, we want to go to the next step whereby we will extract our stream. So we'll just type r extract stream extract. Okay, but no, our input will be our field name. Okay, our input will be our field name here. So field name, then minimum flow accumulate for minimum flow accumulate for streams, we will use the number the 2000 which we set earlier as our threshold. Okay, now here we will just focus with two unique streams. Last I do unique streams vector. Now we are generate the streams, so we'll save this as the raster. Okay, now this is the raster data type for the streams, the area, and this is the vector, the point for the streams. So we'll save this as catchment. Okay, and then we'll save this as streams. That save and okay. After we have completed our area, now we can close the fill them, and now the embook clip. Okay, I want it. You see the rivers. Now if we untick the streams, now we have our streams and our catchment. Now the streams, we can edit our streams. Now these are the vector formats for our streams. We just go to properties, and now we can edit it to topo hydrology, apply, and okay, you see our streams now have changed to topo hydrology. Now we want to flow accumulation. Now this area, now let's assume okay, I think we don't require that. Now let's assume, for example, a dam is to be constructed at a point. Okay, let me see if my Wi-Fi connection is available so that I can just load a base map for us to visualize it. Okay, yes, I have Wi-Fi, so I'll just go to web, click map services, and I just use the standard one. So you can see our rivers. You can see, for example, you can see now. Let me move the streams. You can see the rivers. You can see particularly this river. Okay, if I untick the river, now you can see this particular river and its pixels. Okay, now this is the river which has met the threshold of 2000. Now, for example, the reason why we do catchment delineation is simple. For example, if a dam is to be constructed around this point, okay, a dam is to be constructed around this point. Now, the engineers may want to know which part contribute to the flow of the water at this particular point. So, if they want to establish that catchment area is delineated for the streams which supply the water to the dam, simply for the purpose of like conservation measures, whereby if these streams are affected here, the amount of water in the dam here will be affected also. If a lot of water is drawn out of the streams upstream, the amount of water the dam receives from the stream input will be affected respectively. So let's now delineate the watershed for this particular area. Now I'll take the OSM standard, and I will check this one, the rivers or the streams. So our area of interest is this particular pixel here, this particular pixel. Now our dam is to be constructed here. So for us to establish the catchment area of this particular pixel here, we will use it to calculate the catchment area. So let's do that. Here we type r stream r. Let's just a moment. r outlet, r.water.outlet. This one. Now drainage. Now here our drainage raster should be flow. It should be flow direction. Okay, where is the flow direction? Should be the flow direction that way. Then here we will just uh, click on the our area of interest. You see, coordinate for outlet point. Now, coordinate for outlet point meaning the area of interest whereby you want your outlet to be. So if I just want it to be here, I just click it. Okay. You see, now my point is here. So I'll just go with the original one. Then I'll save this to a file disk C. I'll save it to a file. I'll save this as catchment area that way, and I'll save and run. You will see what happens. Okay, close. Now after I have run, you can see now my catchment area for this particular point, meaning if the amount of rainfall in this particular point changes, the amount of water in this particular point also changes. Okay, that is basically the importance of the catchment. We want to establish the watershed, simply the watershed of this area. Now this is the watershed. Watershed simply is the a place or a region whereby a stream gets its water from. So this is the watershed for this particular area. Now, although this is just a raster form, let's make it a polygon whereby we can edit it. Okay. Now to make it a polygon, what do? We just come here to raster to create the area into a polygon. We just come here and search r vector. Okay, should be vector. Okay, I can't link link vector okay, sorry, not r to vector. Yeah, r to vector, raster to vector, and this is the catchment for our area. Now you just don't specialize anything, just save this as my I just save it as my catchment. I just save it as watershed. I save it as catchment. I'll save it as catchment area, and I'll save it and run. Okay, then I'll close. Now you can see my catchment area. If I want the rest, okay, I just want to have this. Okay, I think I have want my catchment to be included also. Then this is my catchment area. Now you can see my catchment area and its stream. Now if I want to, I just want to, now it's a polygon. Now you can edit it the way you want. I just want it to be an outline black and apply. Now you can see my catchment area. This is my catchment area. Yeah, and that's how we delineate the catchment area for any particular point using the glass tools in QGIS. Thank you for watching. Stay tuned for more videos. Kindly subscribe, and if you have a question, kindly ask. Thank you.